This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Okay. Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations. Welcome to the Master Brewers Podcast. I'm your host, John Bryce, and today we'll be talking with David Kapral. David, thanks for joining us.
Good morning, everyone.
David, you've got a new article that just came out in the MBAA Technical Quarterly just a few days ago, really, and it's about boiler safety and brewing applications. Why don't you give us the rundown on what you've got going on here?
Specifically, my talk was on thermostatic air vents and vacuum breakers, one of the most unsexy things that we have in brewing. I first became acquainted with air vents and vacuum breakers in about 1953 when I was a child, about 10 years old, watching Mr. Wizard. Mr. Wizard filled up a gas can with water, a little bit of water, boiled it, and then capped it. It was a nice, safe thing to watch. Now we have modern day Mr. Wizards doing this on YouTube with 55-gallon drums. It's the same idea. But, when you think about it, this is what we have going on in our brew kettles and in our mash tubs. We're bringing in steam, right? And what's in there? Air when we start. How did the air get there? That's one question. And then when we stop adding steam, the steam will condense and it will form a vacuum, just like we saw with Mr. Wizard and on YouTube. It can crush your heating jackets. Now, the reason I say that and I bring it up now and I wrote the article is because as I go into breweries as a consultant, I look for this. And I'm seeing that many breweries simply do not have air vents and vacuum breakers on their vessels. So they're at risk. Visually, what I have seen is that we don't have complete conversion on one side, or we have scorching all the way around except where the air can't get out. The vacuum breakers are designed to let air out, and I'm sorry, not the vacuum breakers, but the air vent is designed to let air out, and then the vacuum breaker side of it allows air to come back in at the end of the boil. But in our breweries, we have other events going on. We will have, say, for example, in some breweries, we'll have only one steam line going from the powerhouse to the brewhouse. When the brewery tries to run steam, let's say, to the hot water system, the steam going to the brew kettle suddenly is diminished. What that means is you have a collapse of some of that steam and you form a partial vacuum. The thermostatic air vent and vacuum breaker is designed to correct that problem. The whole purpose of this is to say it can happen, and your vents or your jackets can be damaged. At the very least, you're getting uneven performance. So they estimate that about a millimeter of air in a jacket is about the same resistance. It has the same resistance as 21 feet of copper. That's quite a bit.
Yeah.
But when you can see in a brew kettle that you have scorching on one side and it desperately needs to be cleaned, and that on the other side, roughly about a third of the brew kettle is absolutely pure, clean, sparkling stainless steel.
Yeah.
What that's telling you is you're not getting any heat transfer there.
That's right. Now, David, any TQ article that references Mr. Wizard is okay by me, so thanks for that. But I have a couple questions for you in regards to some of what you're seeing out there. First of all, do you feel that I'm always surprised you never see much in the way of redundancy for these thermostatic air vents and vacuum breakers. Why is that? Do you think that seems like something as important as this, you might want to have more than one of them on your vessel?
Often there is more than one. It depends on the size of the vessel, the amount of steam that you have. It needs to be designed in properly by an expert.
Mm-hmm. Okay, well, what are some of the other things you're seeing out there in the field that are scary these days? I mean, like you said, we're in a situation right now where the industry's grown rapidly, and there's, it seems like more manufacturers of everything and suppliers of everything than there's ever been in the past. So there's a lot of new stuff out there, and not all of it's up to snuff. What are some other things you're seeing out there?
I need to stress that brewers need to be out and involved with their process. If you're taking apart a pipe, you need to look inside of it. And part of the reason for that is that you can get biofilms built up very easily. So in CIP processes specifically, as I calculate some of the flow rates going through pipes, it's close to about 4 feet per second, which is not turbulent flow. Turbulent flow happens at about 6 feet per second. It becomes very important because in a line, you can easily have a biofilm buildup unless you have turbulent flow. The way I talk about this to brewers is that in the old days, and some of this I was actually around for, we used a brush ball. And there were brush ball catchers. You can still find brush ball catchers out there. But in breweries, of course, everybody will say if they've been around long enough, we lost the brush ball, never found it, never came out the other end, which means it's in there somewhere. But that's urban legends. It's great. But what turbulent flow does is to give you the effect of the brush ball through turbulence. Is that important? The answer is yeah, it really is. So that's one that I'm seeing out there.
Another thing I've seen a lot lately is air vents that are actually not up at the top of the jacket, that are down low. What kind of symptoms are you going to see as a result of that?
You'll end up, depending upon how the design is, you can end up with the vacuum and you will not be properly bleeding off the air. There are several designs that I've picked up out of Spirax Sarco that show, all right, I have a horizontal external boiler, for example. Where should I locate the air vent? It has to be done properly so that you're actually venting the air. And this is done with different vessels in different places. I'd have to see the one that you're talking about to know whether it's proper or not. But if it's down too low, it's useless. Yeah. The air is, the steam usually comes in at the bottom. The air is released at the top, at the far side of the vessel, usually over the condensate return, so that the air is driven upwards and out as it's heated. And that way you have a jacket that's full of air. If you don't do it correctly, then you can end up with a problem.
Well, anything else you'd like to tell the listeners about air vents and vacuum breakers and steam kettles before we sign off?
Yes. The last thing is, these have been on vessels forever. Ever since brew kettles have been invented and heated by steam. So when you take a look, for example, in Kuntz, you'll actually see some of the old style vessels where the brewer who operated the steam with a steam wheel also had the responsibility of opening and closing the air vent. So recognize that this has been around for a long, long time. This isn't just David Kapral saying this is true. It has been out there. We've lost part of it with automation, but brewers need to go back to the basics and say, all right, I do need to get rid of air in my heating jacket so that I don't cause a vacuum. It'll cause early failure, and that gets very expensive. It'll cause improper heat transfer, and that affects the quality of the product that you're making. As I said, it's not sexy, but it's very important.
So what you're really saying is all those guys out there complaining that they've got too much to do, they don't know how good they've got it. You used to have to juggle even more things that were pretty had a pretty big impact on your equipment.
In some ways, it would be good if we made brew kettles like that and mash tubs like that in colleges, so that the college people would get used to, I've got to let the air out at the beginning of my boil, and I have to turn it off so that I have to open it again at the end, so I let air back in.
Yeah.
That way they gain a really, really good feel for what it's like to brew and have to deal with that part of the utilities.
That's a good point. And for those of you listening, David included some drawings of some of these old kettles in his TQ article, so be sure to check that out so you can get a look at some of these diagrams and get a better understanding for how this stuff works. Well, David, thanks a lot for taking time out of your day to join us, and thanks for your contribution to the TQ and to master brewers in general. We really appreciate delivering this type of information to the members, because I think it's, as you feel, it's important stuff that everybody needs to understand.
Thank you for asking me to talk.
You're welcome. Have a great day.
You too.
Bye.
Goodbye.
Be sure to download volume 53, number 3 of the Master Brewers Technical Quarterly, where you can find David's article, Applications and Importance of Thermostatic Air Vents and Vacuum Breakers in the Brewery, as well as lots of other great articles that will help you make better beer. Just head on over to mbaa.com. If you're not already a Master Brewers member, use discount code 4094 to save $15 on professional membership if you join by December 31st.
Just like that one day, like everyone else did. Calm down, I'm moving too fast.
Next week, in episode 14, John Edwards joins us to talk about using NMR to obtain the chemical fingerprint of beer.
Since there's that one thing that I should have told you.
Say, well, can you kind of get a fingerprint of there's been Brettanomyces activity in here, or there's been Pediococcus activity in here, and does that give a specific look to the residual malt in like a pale ale category or some other category that you're looking at?
Can't get stuck, I can't be losing too much, and then I'm heading out to any other place.